This is a May, June 2023, variant 41 question. And A, state what is Hubble's law. Hubble's law states that the velocity or the speed is directly proportional to the distance. So you can write down V proportional to D. And when you replace the proportionality sign with the equal sign, you must put a constant there, and the constant of proportionality is HO, which is a Hubble constant. So you have the equation V equals to HOD. Then the second point is that the speed V is the speed of recession of the galaxy from the Earth. And the distance D refers to the distance of the galaxy from the observer on Earth. Then part B, which carry 2 marks. The star of luminosity 3.8 times 10 power 31 watts is a distance of 1.8 times 10 power 24 meter from the Earth. Calculate the radiant flux intensity at the Earth of the radiation emitted by the star. The formula to use is F equals to L over 4 pi d squared. F is the radiant flux intensity, L is the luminosity, and D is the distance. So therefore, you substitute the values into this equation, you can get F equals to 3.8 times 10 power 31 divided by 4 pi 1.8 times 10 power 24 square. This will give you 9.31 times 10 minus 19 watts per meter. Then for part C, the star in B is a distant galaxy. The spectral line in the light of this galaxy is known to have a wavelength of 486 nanometer. The spectral line in the light from the galaxy observed on Earth has a wavelength of 492 nanometer. So you can see that the wavelength has increased from 486 on Earth to 492 from the star in the galaxy. Then part 1, explain why the wavelength observed on the Earth is different from the wavelength that the galaxy is known to have emitted. The answer is, for the 2 marks is this, the galaxy is moving away from Earth. Number 2, the wavelength of light from the galaxy is increased by the Doppler effect or the redshift. Then your part 2 is determine the value for the Hubble constant HO. Since you want to determine Hubble constant, you must use Hubble's law. For Hubble's law, we have V equals to HOD. Therefore, in order to find the Hubble constant, we must find the velocity of recession of the star first. And we use this formula to find the velocity of the star. Delta lambda divided by lambda equals to V over C. V is the velocity of the star. And your delta lambda is the change in velocity, which is 492 minus 486. And then your lambda is the wavelength of the same spectral line on Earth, which is 486. So you can calculate your V as 3.7 times 10 power 6 meter per second. Once you know the velocity, you can now find Hubble constant. So Hubble constant is V equals to HO equals to V over D. Sorry, HO equals to V over D. So your V is given to you 3.7 times 10 power 6 meter per second. And then your distance is 1.8 times 10 power 24. So you can get the answer for Hubble constant. This is a summary of the facts that you must know to solve this question. Number 1, you must recall and state Hubble's law. Number 2, you must recall and use the inverse square law for radiant flux intensity F in terms of the luminosity of a source. And this is a formula to use to find the relationship between F and L. Number 3, explain why the wavelength of a spectral line observed on Earth is different from the wavelength that the star is known to have emitted. Number 4, understand Doppler effect and redshift. Explain why redshift leads to the idea that the universe is expanding. Number 5, use this equation to calculate your V. So delta lambda is the change in wavelength. And then this lambda is the wavelength on Earth. Number 6, and finally, we'll call and use Hubble's law, which is V equals to HOD, V equals to velocity, D is the distance, and then your HO is Hubble constant. To calculate the value for the Hubble constant,